Okay, so we're doing still like we did like the inverse and the finding angle extension after 9.3. We just worked backwards from our 9.3 notes, and now we're doing like an extension of chapter 9, which is just trigonometry. Basically, this extension is all about how to solve triangles that aren't right triangles, and we're just gonna like skim the surface so that next year in Algebra 3 or Pre-Calc, you've seen these things before, but you're going to do a much more in-depth chapter on that when you get there. So we're going to talk about law of sines. Today, Monday's going to be law of cosines. Monday, try your best to be here. The law of cosines is a longer formula. There's more stuff to plug into that formula, so it's usually a more difficult formula just to make sure you're doing it right. Law of sines is a nice Friday.
Sounds good.
And then Tuesday and Wednesday next week are going to be review, and Thursday is going to be your chapter 9 test.
Wait, so there's no law of tangent?
We do not have a law of tangent.
Is this stuff going to be on our test?
Yes, I will most likely provide you the formulas.
Okay,
Since
for
we're
what?
doing it skimming.
You get to read it.
Okay.
Oh my god.
Remember, the more with me you are, the easier and faster this will be, and the more time you'll have for your homework.
Yay.
Stop talking. Gosh, people.
Okay, we already know how to solve a right triangle. So give me some tools that we've used in right triangle trigonometry. Pythagorean theorem's one of them. Yep. Oh, that's a good one. Special right triangles. What else can we use to solve? I guess to solve means to find angles or sides of a triangle. Liam? Oh yeah, sine, cosine, and tangent, and I'm gonna write that out as SOHCAHTOA. So we used that SOHCAHTOA two ways, right? Like we would do the ones where it would be like, okay, I'm looking up at a tree at a 50-degree angle. I'm 20 feet from the tree. How tall is the tree? So then I'm thinking about, okay, the tree is opposite. My distance is adjacent. The angle is 50, so I would use tangent. Tangent of 50 equals the height of the tree over 20. That's all. So we would find the missing side length. We also use those, think about your quiz that you just took. We also use SOHCAHTOA to find angles, didn't we? Like the angle for the ramp of the wheelchair. Okay. So we do those problems where we say, okay, I know the opposite side, I know the adjacent side, so I'm going to do inverse tangent. So I'm going to write SOHCAHTOA, and then I'm also going to put inverse trig up here. Now, there's also one other thing that we know about triangles that we maybe use to sometimes find angles, and that's that the three angles in a triangle add up to 180. Okay, so that's always true, whether it's a right triangle or not. But these are tools that we use to solve right triangles. Now, the big question becomes, well, what do you do if your triangle isn't right? If it's not right, how do you find the missing sides and the missing angles? So we have to come up with some other tools. Okay, so in order to solve a triangle, find its missing sides and its missing angles, it must be true that you know at least one side. If you only knew the angles of your triangle, you would know the shape that your triangle would be, but you wouldn't know its size. Is it small, medium, large, extra large? You'd just be creating similar triangles, but you have no way to pin down what size it should be. So you always have to know one side at the very least. Okay? And in addition to knowing one side, you're going to need some other parts. So that could be more sides or more angles or a side and an angle. So you need two other parts. So essentially, you have to have one side and two other parts. So that means you know three things about the triangle. There are three things left for you to find. Okay. Now, Logan, you're whispering something. What are you whispering there? You can see the tops of my letters?
Angle, and it's angle, side. The stuff that we learned last year.
Okay, now this is different, though, a different sort of use of it. It's the same. It's built off of that idea of congruent triangles. You use these as congruence theorems to say triangle ABC is congruent to triangle DEF. Do you remember doing that? Like CPCTC and all that great stuff. Okay, we're not using it for a proof of two triangles are congruent. We're just saying these are the things that we have. I have an angle, a side, and another angle. And so that's talking about two angles and like the side that they sit on. Versus angle, angle, side, I know two angles and then one side that's not in between the two angles. We're going to talk about that one. We'll do an example of that today. This uses the law of sines. And what else uses the law of sines?
Side angle.
Side angle. Okay, if you'll remember, side angle is bad. Isn't it? Spells bad word. You're not allowed to spell it forwards. I mean, this is forwards. You're not allowed to spell it backwards.
Heard her, guys.
Right?
Nope. Clowns today.
Actually, I mean, you could if you wanted to. If you want to be rebel, and in this moment, this next week, this is the one time you come backward on your paper. You want to go for it? Go for it. If that's going to make you feel good, do it.
So SSA is acceptable for the law of sines?
Well, it's not. We're not proving things congruent, so we don't care. It's just, remember, listen, I got a lot of people on their Friday mode, and I need you just a little bit longer. I'm not using this to prove anything. So side angle is not a congruence postulate or theorem. However, all I'm saying is I know a side, and I know an angle that's not in between the two sides.
Can you have your one side measure and then your two other measures with that?
Yep, there's my side measure, and there's two other side measures. It has nothing to do with congruence. It's only about what I actually know.
It's like a descriptive of what.
Yes, just a description of what things I know. Now, that was a bad scenario in geometry because it wasn't a congruence theorem, right? You weren't allowed to prove them congruent by side angle. And it's not bad that we outlaw it here in solving triangles, but it is sort of weird. Okay, so I'm going to put a little asterisk next to it. And this has a name. It's called the ambiguous case. Now, I'm going to talk to you about the ambiguous case, but in the problems that you do for me, you won't have to worry about if it's ambiguous case or not. Okay, I will give you only basic law of sines. Okay, but I want to at least introduce you to this idea so next year when your Algebra 3 or your pre-calc teacher is talking about it, you're like, oh, I remember hearing about that ambiguous case. Ambiguous means unclear, unsure. Okay. So something weird happens. So I like that because that's still for our bad word one, right? So we know something's not right always with side angle. Okay, we always have to be careful with it. Okay, now the other ones that you might recall from your congruence theorems are side and side angle side. And those we're going to do on Monday. Those are going to be law of cosines. Okay. So with this information, we don't have enough to use the law of sines. We have to use the law of cosines. Okay, the more complicated formula for those. Notice that I don't have angle, because I need one side. if I know the shape, I can't pin down the size. So I need at least one side. So angle, angle, angle is not anything I'm ever going to give you. Okay, so first I need to tell you what the law of sines is. You can draw any shaped triangle. Okay, it doesn't have to look like mine. It doesn't have to be a right triangle. Just draw a shape with 3 sides. It does not matter what it looks like. It does matter, bless you, how you label it. Okay, so around the vertices, bless you again. Around the vertices, just do ABC. It doesn't matter where they are. This should have been true in geometry. Opposite of angle A is side A. Opposite of angle B is side B. And opposite of angle C is side C. So it doesn't matter what triangle you draw. You have to label your sides in agreement with your angles. Now, next year, you'll probably work on the proof of the law of sines. It's actually not too terrible. But just so that you have some more time to work on your homework assignment and not spoil anything for your next year teacher, then I'm just going to give you the law of sines today. So this is the rule for the law of sines. The sine of angle A over the side length A is equal to the sine of angle B over the side length B, which is also equal to the sine of C over side length C. So what this is saying is the ratio, a ratio is a comparison of two values. Ratios often look like fractions. The ratio of an angle's sine over its side length is the same for each pair of angles in the triangle. That will always be true. Okay. Now, when you're actually using the law of sines, you only use 2 at a time. So you don't need to write out the whole thing, all 3 ratios. You're probably just going to be solving with 2 of them. So depending on what information, you'll see this in our example, depending on what information you get about a triangle, you might decide that you're going to use sine C over C, and you're going to set it equal to sine A over A. You know, by transitive property of equality, all these things are equal. So I only need to pick 2 at a time.
So for sine A over A, just as an example, is that finding an angle or is that finding the side?
It will depend on what information you get. It will all become clear when I give you an example of numbers. Okay, but for right now we don't have any numbers, so it could be anything. If you have a fraction equal to a fraction like that, how do you solve? Fish?
If you have 3 things, just plug them in and then solve for the 4 or 5.
Yes. How would you solve an equation that looks like a fraction equals a fraction? Cross multiplication. This is a ratio equals a ratio. That's a proportion. So solve by cross multiplication. Good. Solve by cross multiply is what I'm going to write. Okay, now, you know, like Lexi's question about which one is the variable, where is the unknown, that's going to change from time to time. So how we solve will change. Sometimes your missing value will be in the sign, and you'll have to use the inverse to solve. Sometimes it's just a side length, so then it's just a matter of multiplication and division. Okay, so we'll do one example. And this is what you're most commonly going to see for me. Okay, so this is like basic law of sines. Nothing weird because it's either angle, side, angle, or angle, angle, side. I'm not doing that bad word yet. Side, side, angle. Now again, it doesn't matter what your triangle looks like. In fact, on the worksheet, I don't even draw the triangle for you. I just tell you what things are. If you are a more visual person, you can always draw the triangle and label accordingly. Now, on Monday, when I give you law of cosines and when you start studying for your tests, you'll have to think about, like, how will I know for this triangle whether I should use the law of sines or the law of cosines? Okay. I don't necessarily always expect you to memorize angle, side, angle, and angle, side, but here's a good tip for the law of sines. If you can find a pair of matching angle and side, then you can use law of sines. So when you're looking at this picture, what's my matching pair? The C's. So I can write sine C over C, and it's all numbers, right? Okay, let's do that. That would be the sine of 36 over 14 is equal to, and at this point, the only other bit of information I have is angle B, so I'm going to have to do the sine of 118 all over B. That's really like my only option. Okay, so if you can find a matching pair, then create that one ratio. And then with whatever's left over, that's what you're going to find. So now we're going to cross multiply. Okay. When we cross multiply, we'll get B times the sine of 36 equals 14 times the sine of 118. You don't have to do that in your calculator right now. Just leave it alone. You'll type it all in at the end. Okay? Don't worry about getting decimals just yet. If I have B times the sine of 36, how will I get B all by itself? Divide by sine of 36. Oops. Spell that wrong. Divide by sine 36. So B equals, you'll type in your calculators and do this for me now, 14 sine 118 divided by sine 36. Remember that your calculators probably bring in a parenthesis every time you hit sine. So like for 118, you'll have to close that parenthesis before you keep going. Because you want to do the sine of 118 and move on. Type that in and see if we all come to agreement. Make sure your calculator works. This is called muscle memory practice of your notes for today. And you do it. I'm hearing from some different groups, 21.03, and I'm just going to round to the nearest tenth on this one. 21.0. Let us know if you don't get 21. Okay, then we'll know to come look at your work. See if we can find your mistake. Okay. So I could label in my triangle now. I know that side B is 21.0. What else can I find in my triangle? I can find A. How do I find A?
14 squared plus 21 squared equals C squared.
Oh yeah.
Pythagorean theorem? Why not, Katie? Not a right triangle.
Oh, shoot.
That's right.
I know. I thought maybe that would work too. So no Pythagorean theorem anymore, Grace?
Other
You
side
do
thing.
118 plus 36, and then whatever that equals, you subtract that from 180.
And what are you finding?
You're finding angle A.
Angle A. You can find the missing angle. Because you know 2 angles of a triangle, subtract them from 180. Or like Grace said, add them up and subtract from 180. So angle A by Grace's method is 180 minus the sum of 118 plus 36. And someone give that to me, is it 26 degrees? Okay. So now we know that's 26. Now how will you find side A if you can't use Pythagorean theorem because it's not a right triangle? Logan?
You use C again because you know those for certain.
Yeah, you're going to use C again and do another law of sines. I You know how when I said before, like, find that matching pair, and you guys told me it was the C's? You have written this sine of 36 over 14. This is exactly the ratio of every angle and its side, or the sine of the angle and its side for this triangle. So once you have that, you can reuse that. So I love what Logan said. Use the C again because you know it's exact. So I'm going to do the sine of 36 over 14 equals, and now I'll use A. So the sine of 26 over A.
It's always sine.
It's the law of sines.
Oh yeah, I forgot about that.
So yes. I'm going to cross multiply A times sine of 36 equals 14 times sine of 36. And I'm going to write this one, before I just divided by the sine of 36, I'm going to do both sides this time in case you were having trouble. Oh, that should be 20. One of them should be 26. This one should be 26. So what I'm doing there is I'm still dividing both sides by sine of 36, so they cancel out right here. And in your calculator, you do 14 sine 26, close your parentheses, divide by sine 36.
It's 10.4.
10.4. Awesome. Thank you, Rihanna. You guys are doing some great teamwork today. I love it.
This is fun. I like this.
Oh, okay, cool.
There's so many different.
All right, and then I got 10.4. I know all the missing things of my triangle, right? I knew 3 things to start, and I end with 3 things. So I got everything.
Good work.
Now, I'm going to just show you real quick visually what ambiguous case looks like. And again, this is just to prep you for next year. I won't give you any ambiguous cases that you have to worry about. Remember ambiguous cases, side, angle?
So are we writing this in our notes?
No, just pay attention.
Yes.
Okay, so do you see this angle down here is 40 degrees? I know you probably can't read. And then I have this side is 8 and this side is 3.8. So these are like the 3 things that I'm given. Now I have this dotted line here because in order for that to really be 40 degrees, the third side has to be somewhere on this line, just like wherever I cut it off to make my triangle. But where this side is, if it's 3.8, am I ever going to make a triangle?
No.
No. So sometimes side angle, it's called the ambiguous case, there could be no triangle. Okay, well that's weird. And then, like obviously I need it to be longer, so I'm going to make it a little bit longer. Now I could move it back and I could create a triangle that has 3 acute angles. But if I think about moving it forward, I can create another triangle that has 2 acute angles and 1 obtuse angles. So not only could I have 0 triangles, I could have 2 triangles, and it's unclear to me which one it is. That's why it's called ambiguous. And if I make B so long, okay, like it has to be that long. Let me see. I gotta make it a little shorter. I'm sorry. Make it a little shorter. Okay, like over, or maybe a little longer. Okay, on this side, see, it's not hitting the line like where my red X. It has to be 9.2, so it has to be that long. But that's like going too far to actually create a triangle. So I would have to swing it this way, and I can really only make this one triangle. That's the only triangle that works, is to have 3 acute angles. So ambiguous case has 3 possibilities. 0 triangles, 2 triangles, 1 triangle. Yes, ma'am.
Is it possible to make a 90-degree right on that dotted line?
Yeah.
Do a perfect square, a perfect triangle.
You could choose to work with a 90-degree triangle. What?
Well, no, you are fixed. 48, 9.2. There's only 1 triangle allowed for those 3 things. It depends on what this side is. Is it too short to make a triangle? Is it so long you can only make one? Or is it this weird length right in the middle there where I can get two? One acute and one obtuse triangle. Okay, but that's all I want to say about that ambiguous case. However, I want to do one quick example. This is a side-side angle case, but it is one triangle. Okay. So it's not the no triangle and it's not the two triangle example. I'm not going to work it all out. I just want to show you how to solve for an angle with law of sines. Okay, what's the pair that you know here? B's. So we're going to write sine of 79 over 16 equals, and we want to find angle C, the sine of C over 9. When I cross multiply, I get 9 times sine of 79 equals 16 times sine C. Your job is to get C all by itself. You gotta divide by the 16 first. And then how do you get C out of sine? Think about your quiz that you just did.
Secant. Inverse.
Inverse sine. So essentially we're going to inverse sine both sides and solve for C. So you would type inverse sine, and then you could do 9 sine 79, close your parentheses, divide by 6, finally close your parentheses, and you'll get an answer for the angle. So if you can try typing that in, see if you can do that. You should be able to just type in with all this stuff. You will have 2 sets of parentheses in there. 9 sine, 79 close, divide by 6, close.
Oh, I did it wrong.
Do you use your parentheses like I have modeled on the board?
9 times sine.
I got something.
9 sine divided by 6.
Wait, I just did everything else on the board and I got 2 remaining. Do you have to put a thing at the end?
16. Sorry.
It's.
I left off my 1.
I said that and do you want the answer?
Sorry. Put the 16.
It's 33.515.
33.5. Katie's on rolls today.
33.51568.
Okay, now after you find C, could you keep solving? Yeah, now that you know that angle, you could find the third angle. This angle will be rounded. Okay, but then after you find angle A, then you can find side A.
5.4. I always put 5.
That was my bad. I'm sorry, Josh.
3.141516. 5.
Okay, make sure you're doing the side that says law of sines.
Yes.
The back side is for Monday, law of cosines. You don't have to do that side. You only do the side that says law of sines.